We have already seen that in order to define a language, first of all, we should fix an alphabet to be consisting of only the symbols that will be used in that language. For example, if we fix an alphabet as a set of two symbols A and B, it means we will be using only these two symbols in that language. An alphabet is denoted by sigma and it is a finite set. There are a lot of symbols available in the world. We should fix a finite set of symbols for our language. The symbols in the alphabet can be combined to form strings, and the strings can be again combined and recombined to form strings. For example, here A itself is a string, B itself is a string. A and B are strings of length 1. These strings of length 1 can be combined in different ways to form strings of length 2, AA, AB, BA and BB. Then the strings of length 1 and strings of length 2 can be combined in different ways to form strings of length 3. And there is one string of length 0 which is denoted by epsilon. Similarly, there are strings of length 4, 5 and so on. All these are the possible strings over the sigma. The strings of length 0 possible over sigma is denoted by sigma 0. The strings of length 2 possible over sigma is denoted by sigma 2 and so on. And the set of all these possible strings over sigma is denoted by sigma star, which is a union of sigma 0, sigma 1, sigma 2 and so on. And this is an infinite set. So we have infinite number of strings possible over any sigma, which is denoted by sigma star. Now if we define any language over this sigma, that language will be a subset of sigma star. For example, consider a language L1 equals set of all strings of length 2. All these are the possible strings over sigma, but according to this language, the only valid strings are AA, AB, BA and BB. So this language consists of only 4 strings AA, AB, BA and BB, and this set is a subset of sigma star. According to this language, there are only 4 valid strings. So if we create an automata which will act as a recognizer for this language, if we give any of these 4 valid strings, automata should accept it and all other possible strings should be rejected. And a grammar for this language should be able to generate each and every valid string. That grammar should be able to generate all these 4 valid strings. And here we can see this language is a finite set. This language is a finite language. Now we can consider one another language L2 equals set of all strings of length 3. According to this language, there are 8 valid strings. All these are the possible strings over sigma, but according to this language, there are only 8 valid strings. Now if there is an automata which will act as an acceptor for this language, if one of these 8 valid strings are given to that automata, it should accept it and all other strings should be rejected. And a grammar for this language should be able to generate any of these 8 valid strings. And here also we can see the language is a finite set. So this language is a finite language. Now consider another language L3 equals set of all strings beginning with A. There are infinite number of strings possible which begin with A. So this set is an infinite set. This language is infinite. Similarly, consider another language L4 equals set of all strings with number of A's equals 3. Here also infinite number of strings are possible and this set is also infinite. Similarly, we can define infinite number of languages over this sigma. So we can define any sigma, we can fix any alphabet. Over any particular alphabet, we can define infinite number of languages and each such language can be either finite or infinite. And every defined language over sigma will be a subset of sigma star. Now all these possible languages over any sigma can be broadly categorized into different classes. Finite languages like L1 and L2 belong to a class called regular language class. It doesn't mean that only finite languages will be present in this set. This set also consists of infinite type languages. Anyway, the languages in this regular set are comparatively simple. The next class of language is context-free set of languages. Then we have context-sensitive set of languages, and we have recursively enumerable set of languages. From the diagram itself, we can see that the regular language set is a subset of context-free set. It means every regular language is a context-free language. But every context-free language is not regular. There are some languages which are context-free but not regular. Similarly, every context-free language is a context-sensitive language, but there are some context-sensitive languages which are not context-free. And same here. So we just had a broad discussion about the different classes of language. Next, we should discuss about grammar.